we've looked at sound as a waveform. Okay, sound is a longitudinal wave. It's a compression wave is another way of saying it. So my vocal cords move, and that moves air, and that moves air, and so on and so forth. All these particles are moving back and forth in simple harmonic motion. And so visualizing longitudinal wave by seeing the particles is very difficult. So sometimes we represent it as the pressure graph as a function of time or a function of position. So we can see these pressure compressions moving through space if we view that as a sine wave moving through space, even though, of course, it doesn't look like a sine wave. So one of the things we can do with that is we can look, instead of at the actual wave, we can sometimes look at frequencies, because frequencies are sort of how we hear things, right? When you hear a low frequency, boo, or a medium frequency, boo, or a high frequency, boo, right? These are different frequencies that our ears can perceive. So we're going to look a little bit at frequencies using Audacity, an app that you can download for your computer. Here's that's me making 3 different notes. And if we look at those notes up close, if we look in here and zoom in, if I can remember how to zoom in Audacity, you can see, wow, that's not really easy to tell, but there is a sort of a sine wave. It was a pretty low volume. As I got bigger, you can see the frequency. Hard to tell, but the period should be getting shorter as the note gets higher. And then I stopped for a little while. I got to find that. And then I started again, and wow, that was a mess. But the frequency was a little higher because the period was a little shorter. Well, it's kind of hard when you're looking at that. And by the way, you can tell I've got all sorts of weird other frequencies in there aside from the one sine wave I was trying to make. So one thing I can do to analyze this in Audacity, what I can do is I can pick a little chunk there, and I can do analyze plot spectrum. And that's the frequency spectrum of my voice when I was making that note. And you can see the peak was right around 500 hertz. So I was making about a 500 hertz note. But it wasn't pure. There was energy at these other frequencies, not a lot. And then you had these little peaks. These are these weird, some of them are overtones. Some of them are just weird vibrations that I couldn't eliminate because I can't make my mouth into a perfect instrument. Like a flute. It's hard to control all the different cavities, and I don't even mean dental cavities. I mean different holes and gaps and inlets and things in your mouth and your nose and your sinuses. So this was the frequency I was trying to sing, but then there was a whole lot of other stuff coming along for the ride. If I look at this one, there's a lower note, and you can see the first one was 500 hertz. This one's about 300 hertz, a little under 300. And this was a little more pure. You can see there's a whole lot less energy in these other frequencies. So a frequency spectrum is what they call this, is one way of looking at sound. And in fact, it's really useful when you think about how you hear. So let's look at that. We've got longitudinal waves going through the air. And we saw, since if we zoom in on this, let's zoom in on this because it looked a whole lot better. When we zoomed in on this, we saw sort of a sine wave because it was relatively pure. This is the power, or basically the displacement of the little sensor in the microphone. There's pressure, so it's really essentially a graph of pressure versus time. And so the microphone senses this, but let's see, how does this work with your ears? My vocal cords make these waves, make these pressure waves. That pressure gets transmitted across space. It propagates through the medium of the air. But what happens when it gets to your ear? How do we hear? So how do we hear? How do we perceive sound? And it's really kind of complicated. But the bottom line is inside your ear, you've got all sorts of structures that are designed to help process and isolate sound. And one of the things when it finally gets in there to what's called the cochlea, this curved part, there are these little hair cells. They're not really hairs, they're hair cells. And they have different resonant frequencies. They vibrate at different frequencies. To give you an idea of what that's like, what I did like a little simple test. I took a straw, a blue straw, put two red straws together to make one that's twice as big, and I've got a purple straw that's 3 times as big. So you can sort of see these have different lengths. And what's going to happen is I'm going to demonstrate they have different resonant frequencies, okay? This is probably a little different from the hair cells in your ears, okay? And I'll talk about that a little bit after, but let's just see how these things resonate at different frequencies. Okay, so we see that these three have 3 very different fundamental or resonant frequencies at which they'd like to vibrate. Okay, when I do this, it moves back and forth kind of slow. When I do this, it moves, you can't even see it, but it moves back and forth very fast. So this had a frequency of 10 hertz, a resonant frequency of 10 hertz. This had a resonant frequency of, I have to check, 4 hertz. And this one had a resonant frequency of 2.5 hertz. Well, think of having a whole bunch of these. Think of these are hair cells in your ear, okay? And each one of these has a frequency that it likes to vibrate at. And we know that resonance means if I add energy at a resonant frequency, it will make the one with that resonant frequency vibrate more and more. The amplitude will increase. So let's say, for example, you're hearing sound. And let's say you're hearing, of course, these are not audio frequencies, but let's say that the frequency that corresponds to this resonance gets introduced into your ear. Well, this one's going to go crazy. When this one goes crazy, it's going to send a message to the brain, hey, I'm getting that frequency. When this has a slightly different frequency, the red one, the slightly higher, maybe this one vibrates and the purple one doesn't vibrate, okay? So each of these hair cells is going to vibrate with, when it hears the frequency that its resonant frequency corresponds to. So you've got in the brain, in the cochlea, you've got all these different hair cells, and they're not all different lengths necessarily. I honestly don't know. It's probably more they have different densities, and so that's how they have the different resonant frequencies. So as these different frequencies are introduced to your ear, you hear music, and oh, this one went crazy. That sends a message to the brain that maybe this is 440 hertz. I'm hearing 440 hertz. This one goes crazy. Oh, that's 200 hertz. So it tells the brain, I'm hearing 200 hertz. And your brain decodes all this business. So when you see that frequency spectrum that showed the graph of all the different frequencies in there, well, in your ear, there are structures that correspond to each of those things. It's telling the brain we're hearing this much energy at this frequency, this much energy at this frequency. And your brain decodes that, and that's how it hears things like speech and music. Now, one of the things about my ears, at my age, I'm 61 years old right now as I take this video. And there are certain hair cells that do not appear to be working very well for me. So we usually hear somewhere between about, a little below 100 hertz, very low bass sounds, up to, for high school students, it's generally up about 19,000 hertz, up in that range, very high frequency. By the way, 19,000 hertz, you may hear it, you probably won't like it. For me, my max is probably about 12,500 hertz. So you can hear this huge range of frequencies that I can't hear because I'm old and I don't fully understand the mechanism of what happens with the hearing, what's happened to the hair cells in there. because hearing is a very funny thing. I hear all the time some frequencies that you're not hearing, not because they're playing, but because my brain is telling me they're there. It's called tinnitus, and it's not a good thing. And my understanding is it's not that several hair cells are just going nuts all the time. It's that your brain is filling in the blanks, I guess, and saying there should be this sound at this level. So I hear a ringing all the time, very low level for me, thank God. Ask me in a couple of years. But the brain and the ear are so complexly integrated with each other. It's a fascinating science.